Hello, this is lesson 8.3 on equations of linear relations using what we call the point slope form of the equation. So last class we did what we call the slope intercept form, which looks like this, and it gives us the slope, which is m, and the y-intercept, which is b, and from that we can graph it. But this method is also really important. So if we look at this, the graph is showing y plus 3 equals 2 times x minus 1. That's what's been graphed there. So the slope of this graph, if we look at the slope here, it's the rise. We're going to go from here to here. So it's got a rise of 1, 2, and a run of 1. So the slope is 2. And point A has coordinates 1, negative 3. Okay? So then you're supposed to compare that to these things, and notice that in here there's a 1 and there's a 3. Oh, and the slope is 2, so the slope is there. That information is all in that equation. And then we do this again, so the slope this time is 1, 2 down and 3 over, so our slope m is negative 2 over 3. Aha, look at it, it's right there. And the points of B are negative 4 and 1. And again, the 4 is there and the 1 is there. So the signs are a little bit iffy. But let's take a look at this. So we're going to consider this equation. This is like the skeleton or the form of the equation, the general equation. And so what from this, you're supposed to figure this out, but I'm just going to tell you. The point, so the slope here, m is the slope, and x1 comma y1, that represents a point on the line. Okay, so if we go back up here, if we write this one, if we rewrite this question as y minus 1 equals negative 2 over 3 times x minus negative 4, then you can see that the slope is right there, and our x value is there, and our y value is here. So the way I want you to think about this is that these two negative signs, or the minus, belongs to the equation. Okay, so you have to include that in there all the time. That belongs to the equation, and if there's another minus sign, we write it as a plus, but I want you to think of it as minus negative something. Like here, this was minus negative 4. And in this one, this is minus negative 3, which means that it matches the coordinate that we had. Okay. All right, let's try this. So we're going to consider a line with slope 2 that passes through point A at 1, negative 3, and it's shown. So we're going to find the equation of the line. So so remember that the line satisfies every point x, y together on the line. That's what the line is, right? It's the collection of all the points that satisfy that equation. So we're going to have point P at x, y being any point on the line except A, because if we then do this and we do like A minus its own value, we get 0, and we don't prove anything here. But using the slope formula, we have y of point P minus y of point A, which is negative 3, and we have x of point P, which is just x, minus the x of point A, which is 1, and that equals 2. So because we know the slope is 2. So if we write this as a fraction and cross multiply it, we get 2 times y plus 3, sorry, 2 times, sorry, I'm looking at the wrong thing. 2 times bracket x minus 1. Now it's really important whenever you do this cross multiplying that you put brackets around anything that has two terms in it. It might be good practice to just always put brackets around both sides of it, and then you won't forget. And then over here we have 1 times, and I'm going to simplify y minus negative 3. That's y plus 3. Okay? So if I expand this out, I get 2x minus 2, and that equals y plus 3. Pardon me. And then if I subtract 3 from that side and I subtract 3 from that side, I get 2x minus 5 equals y. And then I'm just going to turn that around and write it as y equals 2x minus 5. So that's the equation I get in slope point form, or slope intercept form, sorry. Let's just check that. If I were to graph this, I would find my y-intercept of -5 and count out a slope of 2. So let's do that. 1, 2, 3, 4, 5, yeah. And then slope of 2. So up 2 over 1, up 2 over 1, up 2. That's exactly right. So there's the point, there's the equation in slope intercept form. Okay? Now that's valid for everything. It's also going to work for the point that we had, A, because you can actually use any point on the line to do this. It's interesting to note, and I don't think this comes up in this lesson, there's only one version of the slope intercept form, because there's only one intercept and there's only one slope for a given line. But the point slope form, there's an infinite number because you can use any point on the line for that equation. So that's interesting. Okay, let's look at the equation of the line that has slope m going through a particular point. Actually, I want to talk about notation for a minute here. x1, y1, the subscript. So subscripts, what they do is they denote a particular something. So in other lessons we would have had, I would have done like the area 1. Like often comes up that the area of the total thing is the area of part 1 plus the area of part 2. So that's where this notation is used. Here we're using it that this is the x1 and the y1. It's not good on the graph. Let's look at the equation. So when we look at this, the skeleton of the equation, the part that doesn't change, is y minus equals x minus. That part all belongs to the equation. The y1 and the x1, oh, I should have a bracket here, sorry. The x1 and the y1, that means it's the x and the y coordinates of a particular point, okay? Those have to belong to the same point. It can be any point, but it has to be from the same point, okay? Just like we've got this point with coordinates x1, y1. And then the m, the slope, I'll do that in a different color, that belongs to the line that we're talking about. But the equation always has all of these parts. This y belongs to the equation is kind of how I like to phrase it, because that's going to stay in the equation when you're done. I hope that made sense. If it didn't, come and ask me. Okay, we're going to do the slope formula here. The slope from a to p is y of p minus y of a over xp minus x of a. So the slope is going to be, well, the x and y of p are just designated x and y. And then this is going to be y minus y1 and x minus x1, because those are the values at a. And that's just, I guess that's just showing you that the equation of the line works, or the slope line equation works. I don't know. Okay, next page. I just want to write this equation out at the top so that you have it fresh in your head. So y minus y1 equals m times x minus x1. Okay, that is the point slope equation of the line. I sometimes call it slope point because that's what I called it when I was growing up learning this stuff, so please forgive me. Try to change it back. To determine the equation, oh yeah, the slope intercept is really useful for graphing things, but the point slope one tends to be more useful for finding out things, to find the equation of a line, because that's usually what we have. We usually give the answer, this is customary, to leave the final equation in slope intercept form, but you'll be told which form to leave it in. So the reason you would leave it in slope intercept form in a setting like where you're I guess if you're publishing your work, for example, and you're sharing it with other people, is like I said, there's only one version of that that works. There's only one version. Whereas the slope or the point slope form, there's an infinite number of ways, so you can't compare it with other people's work as easily. You'd have to change it to something that everybody's going to be the same. Kind of like that's why we reduce fractions. But I will let you know if I need you to do that on a test. Okay, state the equation in point slope form of the line through the given point with the given slope. So here's how you do it. You write out the equation, right? Y minus y1 equals m times x minus x1. And then you rewrite it with the parts that you are going to replace. So you go y minus equals x minus bracket. And you might even want to put blanks in there for the parts that you need to add, okay? And then you go up to the information you have, and it's a good idea to label what you have. So the number that's right here is my slope, and this is my x1 and my y1, because those are the points that I've been given. And then I'm going to put my x1 where my x1 goes, so this is going to be 6. I'm going to put my y1 where the y1 goes, which is 5, and I'm going to put my slope where the slope goes, which is here, and there I'm done. Okay? Next one, this is my x1, this is my y1, this is my slope. My equation is y minus y1 equals m times x minus x1. I'm going to go y minus something equals x minus blah blah. Okay, so I'm going to put my y1 in here. Now this is where writing the equation, the skeleton first with the y minus is really helpful, because I need 2 minuses here, right? The red one here belongs to the equation. The green one here, or blue, whatever color that is, that one belongs to the negative. It belongs to the 1, belongs to the y1 point, okay? My slope is negative 4. Let me just fix that. My slope is negative 4, and my x1 is 1. Now I'm not going to leave my equation looking like this, because I don't leave things with a y minus negative 1. So I'm going to rewrite that, and it's going to be y plus 1 equals negative 4 times x minus 1. And I just realized it's asking me to do it in point slope form. Oh no, point slope form, that is this one. Okay, I was thinking slope intercept. There's not enough room here to change these to slope intercept. There's barely enough room to do what they're asking. Okay, next question. So this is my x1, this is my y1, this is my slope. My equation goes y minus something equals m times x minus something. No, you're still learning. I'll write the whole thing out. X1. Okay, and then it's y minus something equals m times x minus something. It is much easier to do this if you write the whole equation out every time. That is also how you remember it, because you shouldn't be assuming that you're going to get given this on the test. Okay? Y1 is negative 8. Slope is 1/2. X1 is negative 9. But I can't leave it like that. I need to rewrite it. So it's going to be y plus 8 equals 1/2 x plus 9. Now, this is a be smart about your lazy moment. You don't have to write this line in the middle here. I'm not going to mark that line. This is what you need to have. But I'm hoping you can see that it's easier to generate this last line correctly if you go through this second line first, okay? Okay, this time we are asked to give the equation in slope-intercept form. Again, there's not really enough room for this, but we'll try. Write small. So I'm going to put my skeleton in, or my basic formula. Although it's asking me for slope-intercept form, I need to start with, or go through, I guess, the point slope form. Then convert, okay? because I don't have the information I need. I don't know what the b is. I don't know what the slope, what the y-intercept is. So I can't do that. I have to go through the point slope form. Okay, so I got y minus y1 equals m times x minus x1. Y minus, so this is my m, this is my x1, my y1. I'm going to live dangerously and just write these in as I go this time. So y minus my y1 is 2 equals, my slope is 5. X minus, now I look for my x1 and it's negative 5, so I'm going to write negative 5. Okay, and then I've cleaned that up. I get y minus 2 equals 5 times x plus 5. And then I have to distribute this. So this is going to be y minus 2 equals 5x plus 25. And then to get it into slope-intercept form, I have to add 2 to that because I have to have the y by itself, right? So that cancels that out. And I get, I'm going to write it over here, I get y equals 5x plus 27. And there's my answer. Okay? Okay, you try the next one. If you haven't already been doing that, I will write it out, but I want you to try it, okay? Okay, my point here, this is x1, y1, and there's my slope. So I have y minus y1 equals m times x minus x1. So y minus 4 equals negative 7 times x minus negative 3 becomes y minus 4 equals negative 7 times x plus 3. I'm going to distribute that out. I get y minus 4 equals negative 7x minus 21. And then I'm going to add, oops, I didn't change colors. I'm going to add 4 to that side and add 4 to that side. So I have y equals negative 7x minus 17. Okay? Okay, next. John and Nikki, oh, this is a great question. John and Nikki were solving the following quiz question. Determine the equation in slope y-intercept form of a line with slope negative 2 passing through the point 5, negative 5. And John could only remember the slope-intercept form, and Nikki remembered the point-slope form. So I'm going to do the point-slope form first because that's what we've been doing. So Nikki has replaced the y1 with the negative 5 and replaced the slope with the 2 and the x1 with the 3. So that's all correct. So let's just continue this. So y minus negative 5 is y plus 5. And this becomes negative 2x plus 6. And then we're going to subtract 5 from that side and subtract 5 from that side so that we get y equals negative 2x plus 1. Okay, now John had a different attack. So remembering that this equation is true for any values of x and y that you have. And we have an x and y that go together. We have x1 and y1. So what John has done is replace the y with the y value that we were given and replace the x with the x value we were given and the slope with the slope-intercept we were given. And we're just left to solve for b. Hello? Sorry about that. Okay, as I was saying, so John replaced what we knew, and we were left with the intercept to solve. Now, if you have an equation with one unknown, you can solve that. So we can solve this equation. So we get negative 5 equals negative 6 plus b, and I can add 6 and add 6, and I get b equals 1. Which means if I put all my information into y equals mx plus b, this time I'm going to leave the x and the y as x and y because that's what the skeleton of that equation is. So I'm just going to put in my slope, which is negative 2, and put in my y-intercept, which is 1, and I get the same thing. Yay, that's this is really important, this idea that you can, you take the information you have and you put it into whatever question form fits what information you have, then that's what you do. Okay? All right, next question. Okay, this question says the line on the grid passes through at least 2 points with integer coordinates. Determine the equation of the line in slope y-intercept form. Well, we can't do directly slope-intercept form because our intercept here is not an integer. So we can't be sure that we're reading it correctly off the grid. So we need to use a different strategy. So we ought to find 2 places where we have integer coordinates. So I see one right here and one right here. So these are the points that I'm going to use. So my slope is 1, 2, 3, 1, 2, 3, 4. So it's negative 3 over 4. And every time I write a slope, I double check that it's the correct positive or negative. And this is a negative slope because it's going down, right? And the point I'm going to use is going to be, I'm going to use this one up here. I can use either of them, but one of these is a 0, and that always makes life easier. So the coordinates of this is negative 6, 0. So my equation goes y minus y1 equals m times x minus x1. Y minus 0 equals negative 3/4 times x minus negative 6. So that's y equals negative 3 over 4 times x plus 6. So y equals negative 3 over 4x minus 3 over 4 times 6. And then I'm going to reduce this. So if I divide that by 2, I get 2, and I divide that by 2, I get 3. So I have my equation is y equals negative 3 over 4x minus 9 over 2. Okay, so does that make sense? 9 over 2, that's 4.5. Yeah, that looks like 4.5. Yeah, there's my answer. Yahoo! Okay, and last example here, we're going to state the slope of the line and the coordinates of a point on the line. So I have, let's see, so this one, my slope here is 1/7, because that's right there, right? That's in the position in the y1 minus yx, whatever, the y minus y1 equals m times x minus x1. Okay, and what I want to do now is I want to rewrite, because this is not written with the minus. I'm going to rewrite y minus 11 equals. And I'm not going to bother rewriting the rest of it because this is already in the right shape. But this makes it easier for me to see that my point is going to be 4 and negative 11, because that's what it is, right? Because I have to go minus negative 11 to get plus 11. Okay. So B, this is already written in the right shape. So my slope is negative 5 over 3, and my point is 7, 9. This one, yeah, this one's already, oh, this one, I can take my y and I can write that as y minus 0 equals dot, dot, dot. Okay, so my slope is negative 3, and my point is going to be 6, 0. Okay, because anytime I have y, same as y minus 0 plus 0, whatever. Okay, this one I have to be careful of because I don't have the brackets here. This one is actually in slope-intercept form, so I have to rewrite this one for sure. So this is going to be y minus 0 equals negative 3. I have to factor that negative 3 out so that I have x, and this is going to be plus 2. And if I multiply this out, negative 3 times x is negative 3x, negative 3 times 2 is negative 6. So now it's at least in slope-intercept or slope-point form. But I still have the plus there, so I want to fix that. So that equals negative 3 times x minus negative 2. So my slope is negative 3, and my point is negative 2, 0. All right? There you go. Sorry for talking so fast, but I was trying to get this done before class starts. Bye.